everyone, we are Group 5, a 5-member group consisting of Cameron, Max, Chewei, Nelson, and I, Vivian. And the paper we'll be talking about today is called Plug and Play Language Models, a Simple Approach to Controlled Text Generation. Transformer architectures has enabled large-scale language models trained on large amount of data to improve state-of-the-art NLP tasks, such as GPT models. However, once these models are trained, controlling the attributes of the generated text becomes very difficult without modifying the model architecture or fine-tuning it. And when we say controlling the attributes, this is to control the sentiment or the topic of a generated text given a prefix or a prompt. So the motivation of this paper is to propose a simple alternative for controllable language generation that combines a pre-trained language model, GPT-2, along with one or more simple attribute classifiers that guide text generation without any further training on the language model. So in the next few slides, my teammates will dive more in depth into the details.
The main baseline used to evaluate EPLM is weighted decoding. Weighted decoding is a technique applied during decoding that increases or decreases the probability of certain words being output, mainly based on word level features such as rarity, specificity, and it's not great with sentence level features like, is this a question? That would require the entire sentence to determine. Weighted decoding is able to generate sentences that are more relevant to the prompt, but sacrifices fluency and coherence to do it. Again, weighted decoding is used as the baseline to compare against PPLM. The main metric used is relevance, and it's measured using simple discriminators.
The paper assumes that the language model uses an autoregressive decoder. An observation is that future generations depend on the XT, and changes in XT start a chaining effect that affects future generations. The paper proposed a way to steer the pre-trained language model by introducing a small change delta HT to shift the original distribution toward the desired attributes. So to do this, they plug in a separate attribute model to make the language model more prone to generate XT prime with the desired attribute by recomputing the inputs, thereby controlling the output vector. For example, in sentiment text generation, the attribute model might just be a classifier with two classes, positive and negative. The gradient loss of the attribute model basically tells how positive or negative an input is. The proposed way is to utilize this information and shift the distribution toward PAX and PX. And it can be thought of as a gradual reinterpretation of the pre-trained language model outputs that will influence future generations. So the pre-trained model might generate the chicken tastes okay, and we pass the okay to the attribute model and recompute the input of the encoder. In the second pass, it generates the chicken tastes delicious, and we keep this output. From this timestamp on, the future generation will be steered toward the desired attribute gradually.
One of the discriminator models used in the plug-and-play paper is a very simple bag of words. This models the probability of an attribute given a sentence. The attribute could be something like space given the sentence by counting up the number of words that appear in the bag related to space. So here it might count planet, orbit, star, and galaxy. They applied this discriminator model to several different attributes or categories, and the results worked well. They performed backprop through this discriminator to adjust the hidden state and achieved these generated sentences with the desired attributes. The con of bag of words is that it's difficult to describe more complex attributes with a bag, and some bags work better than others. So they also applied a single layer discriminator model, a single layer neural network, to steer toward positive and negative sentiment and perform the same generation steps. This addressed some of the cons with bag of words.
So overall, they were able to conclude that their plug and play approach was effective in generating high quality text output without the overall expensiveness of either trying to fine tune the model architecture or retrain the entire model as a whole. This is obviously extremely leverageable because it brings the proficient performance without the aforementioned cost. But as far as performing a comprehensive evaluation, they compared it to several existing models such as Control or WD, other generative text models, and it actually outperformed both of them in terms of topic relevancy while also being comparable to both in terms of fluency scores. And finally, to add to this, there's a very large range of potential applications that they suggested. For example, they talked about language detoxification, noting a study that found 63.6% average toxicity on adversarial triggers generated by a code base. And they concluded that plug and play would be extremely effective in combating this using a simple toxicity classifier in conjunction with a large transformer model. And on that note, we have come to the end of our presentation. We thank you all for listening, and we hope you enjoyed.